Hi everyone. Okay, so how to measure current using a resistor. In the previous video I've shown you a bulb, a resistor, and I explained through some pieces of paper and Ohm's law and all this sort of stuff how you could measure current using a resistor, using mathematics and all that. But in this video I'm going to actually do it. Okay, so this is what I'm going to be using. I'm going to be using the load, of course, this resistor. I'm going to be using a power supply unit, a battery or something like that. I'm actually using a power supply unit. You're going to need various bits of cable and stuff like that. And I'm going to be using, these were, again, bits of cable. You need an Arduino and an FTDI, or if you're using an Uno then you don't need the FTDI because it's got one built in, a breadboard, and that's about it really. Okay, so let's start wiring this up. So I'll plug my USB cable in to start with. Then we need one probe on A0, and we need a probe on ground, in ground, sorry. Then we're going to, I'll need to zoom out now. Okay, we're going to have plus to, from the power supply, I'm going to have plus to one of the terminals on this. This is guesswork really, I'm not sure exactly what terminal's what, but anyway. We've got a plus to there. Then we want power from the bulb, so I'll put one here. Again, I don't know exactly what terminal this is. I think you've got a full beam and a main beam or something. So we'll have that from there to the resistor. Then from the resistor, I'll just make sure this is off. Yep, it's off. And from the resistor to here. I like that actually. Right, so that's the actual circuit done. So what's going to happen here then? I'll just move this out of the way. What's going to happen? Well, it's very simple. When the power's applied, the 12 volts applied, 12 volts is going to run through here, and there'll be a voltage drop. It'll be quite a big one, and then the voltage is going to run through here, or the power is going to run through here, and then back through negative. Very simple up to now. So let's just check this out. I'll apply 12 volts. And here we go, 12 volts. So I'll just show you this. 12. Okay, so we've got 12 volts there. And back over here. So we've got the light on. Now, how are we going to measure current using this setup? So get your Arduino and, right, a word of warning. Put this on the lower side of the circuit. So you don't want to measure from the plus to the load. You want to measure from the minus of the load to the minus of the power supply. In other words, the low side. So if you don't understand what I mean by low side, don't do this because you'll probably blow your Arduino. So research, if you don't understand, research low side before you do this, okay? But this is on the low side. So anyway, the resistor is probably heating up now. Now what we need to do is, we want to measure from the A0 pin. I'll just zoom in there so you can see. Oops, that was a bit mad. Okay, A0, we want to measure from A0 to the plus terminal of the resistor. So that's there. So plus terminal of resistor. And we want ground to ground, which it is ground anyway, but I want to tie the Arduino to it. So ground to ground. So that's done. Right, so that's our connection done. So what have we got now? We've got voltage or power running through the light, and then it runs through the resistor, and then it goes back. But also what we've done is we've wired in parallel to this the Arduino. So current's not flowing through here because inside here there's a massive amount of resistance, so nothing's going to flow into here, it just reads the voltage. Okay, so current's going through here, and then back. So our two probes are looking at voltage basically, well, I'm tying ground to ground. So now what we need to do is look at some code. So I'll do that now. Alright, so this is the code. It's really simple. The first thing we need to do is set VPP. Now, VPP is what I call it. I just call it voltage points. So to work this out, just measure the 5 volts to ground of your Arduino, and then go to a calculator. And then sometimes you'll find that 5 volts or Arduino 5 volts is not actually 5 volts. It's something more or less, usually less. So in my case, I think it was about 4.4 volts. So 4.4 volts divided by 1024 equals a number. Okay, and then copy that number and then paste it in there for VPP. I'm not going to explain why we're doing that, but if you do it, you'll get more accuracy. Anyway, so we've defined that and set it. Then we need a variable called current. Set up serial just so you can keep an eye on what's going on. Now, current equals analog read A0, and that is, of course, the pin for before the voltage drop on the resistor. Okay, so analog read into current, then current multiplied equals VPP, and or in simple words, current equals itself multiplied by voltage per point. Okay. So I suppose it's a little bit confusing really, but it means current equals whatever it is now multiplied by VPP. And what that will do is that, I mean, here you'll get something like that. You'll get a number. It's called a count, but you'll get a count. So in order to get count back to volts, we need to get that number of counts and multiply it by the amount of voltage points. So yeah, that will get it back into voltage. Okay, and then we get the voltage drop, that will be the voltage drop between the start of the resistor and ground. The voltage drop, so we get the voltage drop and then divide the voltage drop by the resistance of our resistor. So the voltage drop divided by the resistance equals current, as in Ohm's law's triangle, like I shown you earlier. So voltage drop divided by ohms equals current, and that will give us a current. And then serial print then current 4, that means show 4 decimal points, and then upload. I need to plug it in first, hang on. And it says done uploading, and I'll just open up the serial console, and it says 0 0 0 0 0 0 0. And now if I apply some voltage, look what happens. So I'll apply the voltage, and the light's starting to glow. We're on 10 volts, 11 volts, and we're on 12 volts. Okay, now I'll just have to show you this with the camera as well. Okay, so to start with, there's the bulb glowing, and now if I look at the power supply, you can see there it says 3.13 amps at 11.9 volts. So I'll go over to the monitor now, the screen, and you can see what the screen's saying. And it's saying more or less the same thing. So the DC power supply is saying 3.14, and this is saying 3.16, so it's very, very, very close. So I'll just put that up a little bit now. Let's say we'll give it 13.1 volts. 13 volts. It's saying here 3.3. So what's it saying over here? It's saying 3.34. Okay, so then I'll have a look at the power supply, and it says 3.31. So 3.31. I'll change this down to, let's say, 10 volts now. Okay, it's saying, so 10.2, it's saying 2.9 amps basically, and let's go back over here. 2.9 amps, and it's saying 2.9 amps. Okay, and that's how to measure current using a resistor. So let's have a quick look at the setup again. There it is. So what have we got again? I mean, we've got the load, and then we've got a resistor of known value, and then we're probing the voltage drop across the resistor, reading it into the Arduino, and then we're just doing some calculations. So we're basically doing the voltage drop divided by the known resistance equals current, and that's all there is to it. Okay, so I hope you enjoyed the video, and thank you for watching. Bye.